The desert locust is an insect that goes through a phase change. If you saw it in most gardens by itself in its solitary state, it would appear green, docile, very much hidden from view as best it can because it's it's eaten by so many. As it changes phases, as it finds its way in being stressed, the insect, as it goes through a phase change, does so because of stress placed on the community.
Welcome to the Feria Cast, where we bring you all things science, engineering, technology, and innovation. Today we are joined by David Auge, a professional engineer, lead accredited professional, and environmental philosopher with a unique mission. He's on a quest to reframe sustainability by studying nature's most enduring systems, the highly ordered society of the honeybee, and the resilient adaptive swarm of the locust. In his book, Man's Search for Sustainability, he draws powerful lessons from these insects that challenge our approach to building resilient systems. In this episode, we will analyze the system architecture of insect colonies and what engineers can learn about balance, adaptation, and purpose. So, David, welcome to the show.
Well, Ezekiel, thank you very much for having me on. I appreciate your audience and the opportunity to share, to give insight to other engineers about what I've had a chance to study and hopefully bring to the table for their own perusal and use in the future.
Fantastic. I'm excited to have you on the show today. So, let's dive in, David. Your background is a compelling blend of hands-on engineering and environmental philosophy. So, with credentials like a professional engineer and a lead accredited professional, I'd like to ask, what was the journey that led you from technical problem solving to exploring sustainability through the lens of insect societies?
Right. Well, Ezekiel, I can start with the fact that I was hired as a design engineer. My background was civil. And in the industry I started with, I had the responsibility of designing chemical equipment for use in the production of synthetic rubbers, rubber types, HNBR, LIBR, chemicals that are foundational just to the production of that type of material. In the role, I found myself asked to help also with a change that was prompted in that industry by the Clean Air Act. This was very close to the initiation of the Clean Air Act in the United States of 1990. And what had happened is we had taken out a particular solvent, a solvent which was identified as a suspected carcinogen with another type of solvent which was not. That resulted in a lot of testing because the total volatile organic carbon that was being emitted from the stacks was in excess of what we were allowed by permit. As a result, I started to do testing. I started the responsibility of getting a better handle on just what these changes were doing to our process. That prompted me to go to school at night and get a master's degree in engineering management with a focus on environmental engineering. And with that responsibility, with those opportunities, I moved from the design department into the environmental department and received my PE in civil engineering with a focus on environmental engineering.
Okay, that is quite a fantastic journey. So, I'd like to ask for our audience of engineers and system thinkers, the honeybee colony operates with remarkable efficiency and order. Can you break down this system architecture for us? And also, what are the key design principles that makes it sustainable?
All right. Well, now we're going to talk about the book that I wrote, Man's Search for Sustainability.
Yeah, yeah.
That particular book had to do, Ezekiel, with trying to come up with a correct platform for my opportunity to open up to the generations that are following me the the structural opportunities that these two communities, that is the honeybee and the desert locust, can provide us to learn about this. It has to come back with varying degrees of understanding of the very term sustainability. Ezekiel, the concept in the mind of most is merely an academic or perhaps a technological type of solution. We need to find some way to use less energy um, to change our maximum sustainable yield of whatever we are currently using to better manage what we've got available to us. That misses the fact that I believe we're not defining sustainability as we should. Now, this might sound unusual from the mouth of an engineer, but I found that the word sustainability has lost its proper definition. As I was pursuing a master's degree back in the early 90s and continued in this particular field, I understood that sustainability was a normative term, and it was used that way in the schooling that I attended. Normative in the fact that it was descriptive, not prescriptive of what was to happen. It's like the word beautiful. Something is more or less beautiful, something is more or less sustainable. But the very concept of understanding the word sustainable was starting with time to grow legs, starting to run away from the very idea that first started from. And as a result, it became something as a goal. This is sustainable, and then we'll go on to the next project. No, sustainable and sustainability has something much more uh, to give us, to provide us than just that.
All right. This is fascinating. You represent the locust, typically seen as a pest, as a highly sustainable organism. What can we learn from the locust's resilience and adaptability that challenges our traditional notion of robust system design?
Okay. What can we learn from the society of a desert locust and its design as a sustainable community? Ezekiel, that's a good question because it's the looking at both of these communities that I bring to the table, the desert locust and the honeybee. I call them the most loved and the most hated insect communities we have in the world. The honeybee, for example, in the United States, we have almost 26 different states that have decided that is the insect of choice, the insect of the state, the particular community they believe should be used and promoted as something to applaud and perhaps even duplicate. On the other end is the desert locust. The desert locust is seen as the most hated of communities, primarily because of the biblical narrative of it being able to destroy a civilization and having done so across the northern portion of Africa, for a millennium. That community, though, from our perspective, is as destructive as you can imagine. But its own strength is perhaps what I want to bring to the table. You see, a desert locust has within its community the ability to move and adapt and change so that nothing can stand in its way. For example, stress. There are things I bring forth in the book I've written about the fact that stress is sometimes seen as a very bad thing on most societies. But within the desert locust, it's the exact opposite. You
Hmm.
see, the desert locust is an insect that goes through a phase change. If you saw it in most gardens by itself in its solitary state, it would appear green, docile, very much hidden from view as best it can because it's eaten by so many. As it changes phases, as it finds its way in being stressed, the insect, as it goes through a phase change, does so because of stress placed on the community. A desert locust will find itself first in the abundance of vegetation. The insect, because of the abundance of vegetation, will increase in population. That increase in population allows for, you know, the increase in vegetation to be consumed. However, that vegetation will not be there forever, and after having been consumed, it could be followed by a drought, a time where the opportunity for it to consume has now gone away. At that point, the phase change begins. The desert locust begins to morph into something because of this that most people recognize because of its change in color and its change in operations. For example, instead of being solitary, it becomes gregarious. Instead of being green in color, it starts to become yellow and black. Because of its color change, it now has the opportunity to be a much more easily identified by other um, predators. But its diet changes in that it will actually start to consume poisonous plants. And these poisonous plants, and the green color now changed to yellow, will result in those other predators not eating it. It also changes its size of its brain. It increases by 30%. Its legs actually change. And in its gregarious form, it starts to operate as a group, as an organism, that instead of a single desert locust or a single what appears to be a grasshopper, it's now in the hundreds of thousands to millions to perhaps even billions. That strength, that dynamic requires the United Nations to combine in order to fend against its voracious appetite that could take most nations, especially in Northern Africa, right to their knees. They have to detect where it is. They have to detect how it grows, in what direction it's moving. All of those things are strengths that we can see because stress did not reduce, but they increased the ability of this insect to grow, to foster its opportunities, to actually increase its brain capacity so that it can do things beyond, in many of our understandings, our wildest imaginations. That's the strength that something like a desert locust can bring to the table. And I contrast the management of stress of the insect community of the honeybee versus the desert locust, because in contrast, the stress that can impact the honeybee and the operation of it actually can bring it to its knees. There's something called a colony collapse disorder in the United States. Since 2006, it's gained a lot of attention because many people are trying to find out what stressor, what uh, what stick on the camel's back, what was the final breaking point for this particular community to just fail. In some cases, 40 to 50% of colonies just collapse, and we're talking bee hive colonies that result in a lot of concerns about the pollination strength that we have here in the United States for future operations. So stress is a negative for honeybees, yet it's great, very much a positive for desert locusts.
Okay, that's really insightful. So, you frame sustainability through concepts of mimesis and poesis, like the locust chaotic adaptation. So, can you explain these concepts in simple terms? And also, how can engineers and designers balance these two forces when creating new technologies or systems?
All right. Well, perhaps I can bring it to the table by mentioning the fact that the mimetic view is regarding the world as having a given order and a given meaning, and thus seeing human beings as required to discover that meaning and conform themselves to it. Poesis, the second one term that you mentioned, is a way of seeing the world as just so much raw material out of which meaning and purpose can be created by the individual. Prior to about 150 years ago, the mimetic point of view was the primary one. People saw around them the changing of seasons, the movement of certain cycles that had to deal with the planet on which we live. And it was the understanding of those that brought us forward into making sense out of what we're to do and how we're supposed to do it. Many people might say, well, that's just biomimicry, David. We're just looking at the fact that there are things in nature that seem to do things better than we do. Let's learn from them. And perhaps that's a good way to look at it. Michael Phelps, for example, the Olympic swimmer who did so well because of um, he did well because of a great swimmer, but also to his advantage was a swimsuit where the material actually mimicked the skin of a shark. And because it did so, it gave him less friction in the water and thus an advantage in his speed to do well in the Olympics. The other point of view is the poetic point of view. And this is the majority way that most of us as engineers look at things. It's merely the fact that the world has raw materials and we're not to exceed the amount of raw materials we use as we move forward. This misses the point of view that I think my book tries to bring to the table. We can learn from nature. We can learn from these communities, the honeybee community, the desert locust community, and from having learned, we can then go forward, not at each other's throats from a political standpoint, but from just looking at a third grouping, something like that which is in nature, that culture that is somewhat separate from humanity, but gives us enough of a parallel that we can learn from it.
Okay, so being a professional engineer yourself, what is the most significant flaw in how the engineering profession approaches sustainability that your study of insects reveals?
All right. Well, let me say the concept of an engineer to be able to see the entire larger picture of what we have before us. Perhaps that's what I can say is the understanding of the flow, as you mentioned. Um, for example, some flows and things that we need to put on the table, and the reason why I wrote the book is that there are conflicts that are so politicized in nature that a step forward puts you on either one camp or the other. And what I'm trying to do as an engineer is to understand that there are paradoxes that we as engineers need to be aware of as we move forward. Ezekiel, have you heard of the paradox of the commons?
Not sure I've heard that. I'd like to hear about it now.
Okay. Well, imagine you have a shared pasture where everyone is free to graze their cattle. Sounds ideal, doesn't it?
Yeah, yeah, sure does.
Okay, but here's the catch. If everyone acts self interested, then the pasture gets overgrazed and eventually destroyed. Individuals acting independently according to their self interest deplete the shared resource, this pasture, even though it's clearly against everyone's long term best interest. Now,
Hmm.
why is this an issue as an engineer? Well, it challenges the notion that individual action always leads to the best collective outcome. Think of national parks or fisheries. It highlights the need for regulations and cooperation to manage shared resources sustainably. You get from this the common can be protected by regulations. That's one side of what an engineer has to understand, this paradox of the commons. Those commons, of course, being water or land or the air in which we breathe. But on the other hand, there's also the paradox of the invisible hand. As an engineer, we have to know this one as well. Are you familiar with the paradox of the invisible hand?
Wow, that's another new concept I'm hearing about. Do you mind telling me?
Sure. Well, imagine a world, once again, where everyone acts in self interest, yet somehow society benefits. For example, there's
Mm-hmm.
a baker who bakes bread to earn a living, not to feed the community, yet by doing so, the baker provides food for many, many people. The paradox reveals a fascinating aspect of human behavior. It suggests that our ambitions can unintentionally benefit others. It raises the question about the balance between self interest and societal good. Can we rely solely on self interest to drive progress, or do we need a guiding hand to ensure fairness and sustainability? The invisible hand can be promoted with deregulation. From Adam Smith and Wealth of Nations, we kind of bring that to the table. So here you are as an engineer, you've got two paradoxes. You've got a set resource that's going to be shared by the county you're in. It could be water, it could be the land, it could be the air we breathe. And you see the regulations necessary for the wise use of that resource. But at the same time, you see that the invisible hand and the self interest of those industries to produce something creates by itself the need for the roads, the need for the maximum and essential use of those resources. Both of these paradoxes play against each other. As an engineer, you need to look at the entire spectrum of what you are going to be dealing with in a project. And both of those paradoxes need to be brought to the table. One could be the paradox of the commons, could be, well, these desert locusts are getting out of hand. They need to be regulated. They need to have the United Nations, as we do actually in actual practice, in place to keep their marauding bands from using, consuming, and destroying what we have. But in the paradox of the invisible hand, those bees are actually not desiring to pollinate all of the land we have around us. They're doing so because they're gathering nectar, they're gathering pollen, they're gathering water for their own difficult summers that are coming up, or difficult winters. See, and we gain from their use. We gain from the honey that they produce. We gain from the pollination efforts which they do, but that wasn't their original intent. So the paradox of the invisible hand could be seen as the honeybee. The paradox of the commons could be seen as the desert locust. And as both of them come to the table, we as engineers need to understand that both are going to have to be addressed.
Oh, wow, that's fantastic. I mean, I just learned a couple of new things here from that response you gave. So I'd like to ask, David, if you were to advise a city planner or a civil engineer designing a new community, what is the first principle from the insect world that you would tell them to apply?
The first principle from the insects world, all right, that I would tell them to apply. Well, a good part about sustainability and about most of these communities out there is participation and expectation. Those two words would be an important part about community involvement. If you had a community in the desert, the need for water would be paramount. Yet if you had a community that's in the jungles of South America, the water element may not be as important as it would be elsewhere. And participation of what they expect and the expectation of what they need as a resource would be two things to bring to the table. Many people believe that this can be dictated from on high, but in understanding sustainability, especially with the honeybee and the desert locust, it gets down to the individual participation of those members. They are a small, many people might believe, insignificant part of a larger puzzle, but they all have to be tapped in order to best understand the larger puzzle of what's going on.
Okay.
Does that help, Ezekiel, or can I help anymore?
Yeah, sure does. Sure does. That was a great response there, David. So I'd like to ask for a young engineer just starting their career, what mindset or habits would you encourage them to develop to contribute to a more sustainable future?
Well, a big part of understanding as an engineer is the fact that you are to grow with the resources that are around you. I mentioned expectation just a few minutes ago. The expectations are going to change. They're going to change as an engineer's environment changes and the ability for a number of things on the table to change as well. For example, water. Let's just go a couple hundred years ago. Availability of water in a community was a necessity. Then it became an availability of water in the very close proximity to the house. Now that availability is not only in the house, but the quality of the water increases because we expect water to be at a certain health level. And then now we're even purchasing water because that health level continues to step further and further. And the engineer needs to know that expectation will not stop. And just the same way with sustainability, it will not stop. There will be a continual movement forward as to what you have available to you and the expectation of your customers, uh, the project you're working on, the society that you're in. Best way to get there, though, is to include participation. We have a lot of engineers that find themselves saying, I've got the technology, I've got the textbooks, I've got the general understanding of what needs to be done. Put me into the back corner of that cubicle and I'll step forward and give you a solution that you need. That is dangerous. They have to participate in the larger understanding of the uh, the individuals that expect something to be sustainable in the long term.
Okay, so David, part of the theme of this podcast is centered around innovation. So for that reason, there is a common question that I like to ask every guest I have a conversation with on this podcast. So tell us, David, in your life's work, bridging engineering rigor with environmental philosophy and the wisdom of insects. So what does the word innovation mean to you, and how does it relate to your work?
How does the word innovation relate to me? And how can I bring it forward in this concept of sustainability?
Yeah.
Okay. Well, Ezekiel, I would have to say that the concept of sustainability is currently looked at from a poetic standpoint, a bunch of raw materials. And as a result, the innovation, I believe, that can best be brought to the table is to look at the world in which we currently find ourselves. Look at the natural aspects, in this case, societies, one that's very much loved, one that's very much hated, and learn lessons from them. Uh, you know, go to the ant, you sluggard, observe its ways and be wise is a proverb that many people bring to the table. Ants have a tremendous community, and underneath the ground, they have some tremendous abilities in order to work what they've created in the long term for people to learn from. I remember as a small child, I think I desired to be an entomologist, but I found that there were insects that were just absolutely fascinating in their ability to change, to transform, to move further in their development to handle the situation that they're in. That would be the innovation I think that would bring to the table for an upcoming engineer the growth that they need. Don't stop with just a bunch of raw materials. This world is much more than that. There are some fascinating things that are in place in the world of nature.
Okay, that's great. So, finally, David, for our listeners who are inspired by, to think more deeply about these ideas that you shared, where's the best place for them to go?
Well, I have a website, davidaugebooks.com. My last name is spelled Auge, so there's no periods, davidauge books.com. I talk about this. I'm also in the process of writing another book, and that will hopefully be on that website soon. They would best go there, or they can go to amazon.com and look up my last name, and I have my book for sale there.
All right. I'll also be sure to link that website to the show notes. So, David, it's been a really insightful and fun conversation with you, and I'm excited to have you on the show today.
Well, it's nice to be here, Ezekiel. Thanks for inviting me.